Morning everybody. Unit 4, Lesson 1, Topic 1, Text Files, and we are going to discuss some theory regarding text files. So, let's just have a look. Remember first of all that throughout the course we are really looking at programming concepts that can be reapplied in most of the programming languages available. So whatever we discuss and use would be usable in another language. So just take note, in Visual Basic specifically, there's two methods, read all text and write all text. We're not going to use them because we need to have a look at file processing that is available across the board between many different programming languages. This doesn't really let us use files the way that we need to. So we need to have a look at the stream writer and the stream reader classes and how to use them. Okay, so let's first of all have a look at what is a sequential text file or a sequential access file. It's the most basic type of file where we can store data. We can open it using any editor. We would prefer if you guys use something very simple like Notepad, just because Word adds very often default file extensions and then the data is saved in the wrong format. And using text files then, or sequential access files, I've got characters that's saved in the file. Characters A, B, C, 1, 2, 3 that you guys can view and have a look at. First of all then, be very careful of the settings of the computer that you're using. So normally programmers would need to see the extension of files. It's hidden to normal users because they don't need it. But as programmers, we really like to see the name of an extension. So employees.txt, whatever the extension of the file would be. Normal users are only interested in the type. Is this a Word document or this or that? Okay, so whenever I read data from this file, I can read one character at a time, or then one line at a time. And normally we're going to use the one line at a time sequence just because it's easier. A character at a time. If we read that, we need to add it together, concatenate it still. But reading a whole line at a time normally makes sense because I would store my records, my data, line per line. We've got something called a file pointer that we're going to discuss a little bit further now. And this is the thing that keeps track of where the data in the file would be situated, where next we're going to read or write. The file pointer is then very similar to the cursor that we see. So right at the start, if I've got some data in a file pointer would be placed before the data. After I read a line, the file pointer moves to the start of the next line. It doesn't read the line yet, it just moves to the start. If I read the next line, file pointer again moves to the start of the next line. So if I've read 1, 2 lines, file pointer points to before the next line's data. If I were to read this line, file pointer moves to the end, there's no more data. And now if I ask the file pointer, it can actually tell me, yeah, you reached the end of the file. Okay, there's no more data in this file. So we need to know how the file pointer works. When I open a file to read it, file pointer is placed right at the start. As soon as I read one line, file pointer is moved to just before the next data. If I read a line again, file pointer would be moved to just before the next data. If I read the last line, as soon as I'm done, file pointer would tell me. If I ask it, are there another line? It's going to tell me no. No, there's no more lines available for you to read. So this file pointer keeps track of the next character to read or to write, and we're going to use this to know when I've reached the end of the file, if I am reading from the file. Second thing that you need to know is that we can either have a read operation on a file or a write operation, not both at the same time. So I will open a file for reading, and now I can only read from that file until I close the file. If I then open the file for writing, I can only write to the file. Okay, so either read operations or write operations, they can't be mixed in sequential access file. Closing a file is then real important. When I close a file, it saves the last data that might be in the buffer, so in the memory of the file, to the actual file, and it closes the file and it makes it available to the operating system, to any other programs that might use it. So how do we normally store data in a sequential access file? We are now normally going to use one record per line. We're going to use a special character, a special delimiter. It's normally a comma, but this can be anything that you choose. Anything that won't be in the normal input range. So a hash character, for example, is fine. Semicolon would be fine. I would choose it depending on the data that I normally have. So this delimiter would separate each field in a record. Remember, we said one record per line. If I go have a look at some data, and let's say I've got some student data that's saved, and over here the sequence is student number, a comma, the name, comma, the surname, a comma, and some course code. One record per line. Each field is separated by a comma. So actually I need to highlight that as well, hey? Let's just go highlight, highlight, and highlight. So here you can see each one of the fields ends with a comma, except for the very last field. So if we take Peter and Corsi, then that consists of a record. It's all the data of Peter and Corsi that I might have. So student number, name, surname, and the course code. I'm using a rather old course code over here. See, there was a spelling mistake. Fixed it. So one record per line. Each field is separated from the other field by a special delimiter, a special character that I choose. So a comma would be it. I would, for example, not use a space, because some people might have more than one name or more than one surname. In this case, I'm not going to use a number, because I've got numbers in my student number and in my course code. I won't use an alphabet letter, but I can easily decide to use a hash instead of a comma to separate the different fields. Then I just need to always do that. But commas are normally rather okay. So one record per line, a special delimiter, normally a comma, but it can be anything else that separates each field. We're not going to add additional spaces, because that just stores more and more data that I don't need. And very importantly, I'm not going to do like any formatting. So if I had to store some kind of a price, I'm not going to store it like that. No formatting at all. So simply the price, just the number itself would be stored. Okay, no formatting. Normally we're going to use .txt for the extension of the file on the file system. If you know something about Excel, then we can also use .csv so that the file can be opened in Excel. I'll show you a little bit later. And then we can manipulate the data in a spreadsheet. So, the student data, and really important that we know exactly what's the format in which the data would be saved. If I need to read from the file, I need to know. It's first the student number, then the name, then the surname, then the course code, so that I can treat the data as such when reading it. Over here's another example of product data, and again the format would be the product code, a description, then the unit price, what's the cost of one apple or one banana, and then how many I've got in store, the quantity in store. So again, one record per line. The different fields in a record are separated by a comma, and I don't have any formatting on things like prices. Now, the important part, guess what? I can, if I want to, create this file in Notepad. And then my program can already read the data from the file if I need to. It's really simple to create a file like that. I've got a program here. Program 91. In the next video, I'm going to do the planning and write the program for you. If I go to the project folder where I can see the forms, there's a bin file. In the bin file, I can go click on debug, and here in the debug file, if I don't specify any file names, this is exactly where the file would be saved. So if I want to create a new file, I don't want my program to create it, I just want to create it so that my program can read it. I can right click, choose new, choose text document. I can enter the name of the file that I want to and have a look. I can see the extension there, .txt. If I open this, it opens a notepad, and I'm just saving a lot of names. So I can save some names that I want the user to initially have in the file. Whatever names I want to save. I can choose save, Control S, close the file, and there I've got a data file. As easy as that. My program actually doesn't need a file initially, so I can delete this. Either I can use it or delete it, doesn't matter depending on what the program says I need to do. Just for some extra information for you, there's an exe file over here. That's the executable file of the program. That's the actual file that I would one day give a user to use. Okay, so like I showed you, you can, if you want to, create the file in Notepad. And now the other bonus that we've got is that after I ran my program, I can go have a look at the file that was created. I can open it, I can view the data, I can make sure my program works perfectly fine. So I can verify that the program created the file and that the content is whatever it is supposed to be. Okay, if we just then have a look at some more information regarding sequential access files. So up until now, input of our application came from the keyboard. And these would be saved in the temporary memory of the PC. That's the RAM memory, random access memory. What's the disadvantage? Moment that, oops, we've got load shedding, or that you stop the program. All the data is gone. So up until now, we had to every time type in all the data for my program. If I can save data in a file, then I've got the added advantage that I've got a permanent storage medium now, the file. So the data can be saved and retrieved then. So my input of my application can either come from a keyboard now or from a file. Output of an application can be either the screen, that's again the data that was stored in the random access memory is displayed on the screen, or I can save my data to a file so that it is permanently stored. I can access it at a later stage. Okay, so data is saved in the format of a sequence of characters, one character after another. And very often in programming, we're going to call this a stream of characters. You're going to hear this word stream again. I will then have an output file. That's when my application writes some data to a file. Or an input file. This is when my application reads data from a file. As already mentioned, sequential access files are also called text files. And I've got an extension of txt. I can open them with Notepad and I can verify that the data is saved. And now, important to know, whenever I'm reading from a file, I will always read in consecutive order. That means one after another. So, in order to read the second or the third name, I need to start at the first one, then the second, and then the third. I can't jump around in the file. Okay? We've got other files that we can do that with, but not those that we teach to beginners. So, sequential access. First the first name, then the next name, then the next name. And again, when I'm writing, I'm again going to write in consecutive order. Either one character after another or one line after another. So if I need to read the 10th line, I will need to first read the first 9 lines in order to get to the 10th line. We then normally read one line at a time, not one character at a time, and we write one line at a time. Nice thing is that I can give you an algorithm again. So, if I want to read from a file, I normally need to follow these steps. And again, algorithm steps given to you, go learn them, and then doesn't matter which programming language you use, those are the steps that we're going to execute. So first of all, I need to test if the file is present. If I'm reading, then it obviously means there's got to be a file. So first test, if there's a file, then I will open the file in read mode. I'm going to have a loop until I reach the end of the file. I'm going to read a line and then process the line. Do with whatever the line that the program specify I need to. And per program this would obviously differ. After the loop, I will need to always close the file. Really important that you remember that. And then if the file isn't present, I'm normally going to tell the user, oops, couldn't read the data. Okay, so I need to do something really important, that we always test if a file is present before opening it in read mode. My instructions that I'm going to use to open the file will actually give an exception if I try to open a file that doesn't exist. So we know exception stops the program, so I don't want to do that. And the best coding then first check if the file is there. Only open it if there's a file present. I also have some algorithm steps to write, and over here many data items to a file, because I can write one item at a time to a file or many. So if I've got, for example, will have a lot of data stored in an array, these would be my steps. I'm first of all going to open the file in either create or append mode. I will discuss that in a moment. And this depends on your program specifications, whether the program says create mode or append mode. Then I'm going to have a loop until my end of my data. So if my data is saved in an array, then it's a loop from the first element to the last element in the array. I'm going to write the one line. After the loop, I need to close the file. Real important. I also have an algorithm. We're not going to use it very often, but sometimes we need to add only one thing at a time to a file. Program 91 is an example of this. So we're going to have a look at program 91 first. Then I simply open the file, normally in append mode, because I want to append means add at the end. I normally want to just add my data at the end. I'm going to write the file or write the line, close the file. And if I only have one piece of data, then I would not have a loop, eh? So open the file, write my data, close the file. We're not really going to do this very often in a program, because using a file takes a lot more processing time than using the memory. So normally our programs would work like program 94 and later, where we first save the data in an array and then save all the array data at once to a file. But we need to know how to use both options, so we need to have a look at it then. Okay, so now what's the difference between create and append? In create mode, then the computer will create a new empty file for me. So create means there's no file, whoop, create one for me. Do you remember, if the file already exists and I use create mode, then any previous content that might be in the file is deleted when I create the file. So we can say the previous. Any previous content would be deleted. You guys need to know what will happen to the existing content in a file if I open a file for create. It would be deleted. If I use append mode to open a file, then the computer will open the existing file, so the data can be appended. Appended means add at the end. So it's a term that us programmers use. Append means add at the end. New term for you to remember. I need to know what would happen if there wasn't a file. And if there isn't one, then the computer will create a new empty file. I can actually go and open another line or create another line here. What will happen if a data file is opened for read mode? So computer will open the existing file so the data can be read. Let's say from the start of the file. If the file does not exist, what's going to happen? Then the program will raise an exception. and stop. If there is no exception handling code. So if there's no try catch statement. Okay, but I don't need to. I just need an if statement before I open the file to test. I don't need a try catch statement really. Very important, we need to open a file before we want to use it. We need to close the file after using it. The last data in the file would be saved to the buffer, and the file is made available to the operating system. Has it ever happened to you that you take a memory stick, plug it into the PC, copy some files to it, pull it out, and then the files isn't on the memory stick? The reason for that is that you didn't close the file or the memory stick correctly. That's why we first go and eject the memory stick. That makes sure that all the last data is saved to the memory stick and it's closed correctly so that I don't have any data that's lost. The same is going to happen if I don't close a file. I might have some data loss and the file might be inaccessible. So I can't open it with other applications. It's going to say, this file is busy, you can't open it right now. Okay, so there's a possibility of that. So we need to know, I definitely need to close the file. So I've already shown you where to locate a text file if it's created in Visual Studio. The short answer would be go to the bin debug folder. Normally, when you're going to write programs, we want you to only use the name of the file. So in this example, employees.txt. You see, if we define the file name as a constant, and the best place for that would be in a module, then this file would automatically be saved in the bin debug folder. If you hand in a project, you also automatically hand in the file that was created. If anybody needs to have a look at the file, they can find it easily. So define a constant in the module, give the name of the file without any folders, and then the file will automatically be created in the bin debug folder. Rather important that you need to know about the efficiency of operations. So efficiency means how quick, how fast it would be. So if I need to access the memory of the PC, the RAM memory, is it fast or slow? If I need to access a file, is it fast or slow? So accessing the normal memory, so the RAM memory, is super fast. Accessing the hard disk of a PC to a PC that's slow. To us humans, it doesn't take even a millisecond. But to a computer, it says, oh, sure, it's slow. And then accessing an external storage device, like a memory stick, apologies, would even be slower than accessing the hard disk. So normally an application will first save the data in an array in the RAM memory, and then once you've got all the data, once at the end of the application, we're going to save that to a file. And then right at the start of the application, normally we're going to read the data from the file and store it in the memory of the PC. So normally an array. But before we can get to an application like this, we just need to practice the first beginner programs, accessing text files. So we're not starting with that scenario immediately. What do I need to do if I need to use VB.net to write an output file. So there's a few steps. I first of all need to declare a variable. Normally you're going to use a dim variable to declare a local variable, and we are going to define a variable of the type stream writer. So this is a class that somebody coded already that we are just using, and it saves data to a file. So first of all I need a variable. Then I need to open the file. So I'm going to open the file for output, and I've got two options, either to create the file or to append to it. And the statement to create the file would be io.file.create file and the file name. So if you've got a constant, real good. Or I will call append text if I want to add to the end of the file. Thereafter, once the file is opened, normally in my loop, I want to write one or more lines to the file, and there's a write line method. There's actually a write method as well, but normally we're going to use write line. And it's at this stage where I'm going to add the commas in between the different fields if I've got more than one field in a record. If I need to close the file, then there's a close method that the stream writer object would need to call. Okay, so for the object that we created, we just simply need to call close. If I'm going to read from a text file, so now I need to get some input from the text file. What's the steps that I need to follow in VB? So first of all, I will need to declare a variable, this time of the type stream reader. So a reader reads for me and a writer writes for me. Remember, we can only do one of those two things at a time. So first of all, a reader object, and normally this would again be a local variable, so a dim statement is good. I can check if the file exists. So the method call, and this would be a function, because it returns a boolean true or false. io.file.exists, and again the file name needs to go as a parameter, will give me a true or a false, and that will tell me yes, the file is present or not. Now I need to open the file for input. That creates the stream reader object for me, and the statement that I need to use in VB is io.file.openText, and again the file name. Then I need to test if I reach the end of the file. This is where that file pointer would be used. There's a peek method, and the peek method gives me -1 if I've reached the end of the file. So peek method, so I know it's a function, gives me -1 when I'm at the end. So I can now either use a do while or a do until loop, depending on whatever I do. So do until, do the following until you get a -1, or do the following while the peek method doesn't give you -1. Okay, so any of those two loop statements would be perfectly fine. Then I'm going to read one line at a time, and the line is given to me in the format of a string. So I'm going to save the string that the read line method returns. A little bit later we're going to learn about breaking up. Remember, that line might consist of different fields that's got commas in between, so I will need to learn how to break up that line, but luckily there's some string manipulation methods that I can use. And the final thing that I need to do is to close the file. So I'm going to call the close method of the stream reader object. Okay, That's it for now. We're going to next have a look at an example. Program 91. Thank you.